Yes, good morning all. See, if you can recollect, in the last lecture of Bode plot, we have seen how to draw Bode plot for gain, plane gain, and then if you are having a pole at origin, then how to draw the Bode plot. Now, in that, when pole was at origin, we had seen that with minus dB per decade gain, the line will be there. So it's a slope of that line was minus 20 dB per decade. And then we had seen if repetition of the pole at the origin, that means s square, 1 upon s square is the transfer function of that of that particular system. Then in that case, the slope of that line Bode plot was minus 40 dB per decade, right? On the same line, now next thing, so your gain was A, है. Then we had seen B, that is a pole at origin, and now I am talking about C, that is we'll see 0 at origin. And I am talking about single 0. So I'll write single 0 at origin. And then what it will be if double 0 is there, right? That means at the origin 2 zeros are there. Then what is going to happen? Okay. So if I'm saying GH of S transfer function, which is equal to S single pole at origin, correct? So what I can write? Yes, GH J omega. I can write it as J omega. I can write the same thing as 0 plus J omega. Alright? That means if I want to talk about the magnitude of GH J omega, then 0 square, omega square and under root addition of these two. So ultimately it is going to be omega only. No need to think of. On the same line, if you are talking about angle of GH J omega, very much clear over here. J omega means positive direction of y-axis, no real part. So, or even if you can say, I'll write it over here, tan inverse of omega by 0. So omega by 0 means infinity. Tan inverse of infinity is 90 degrees. So whatever might be the value of omega, angle will be 90 only. All angles for this plot will be 90. So we'll try to see how the plot will be there, right? Before that, yes, we would like to draw it on W plane. First we'll see on W plane how it is, and then we'll go for the Bode plot, right? So I'll say real GH J omega and imaginary GH J omega. Right? So if you are trying to draw this, it is having magnitude omega and at 90 degrees. So very much clear, yes, I should draw it over here. And see, this will have magnitude to be equal to omega and angle is 90 degrees. So this is going to be the vector. Correct? Then what will happen for omega square, we'll see separately. Right? I think this thing is clear. So if I'll mark it this thing as 1, over here. Alright? So this is graph of that 1. Then second will be omega square. S square. Then what it will be, we'll see. Now, so we want to plot, so we'll require some points. So let us say omega, then gain, that is, I'll write gain, that we had seen it is equal to omega. But if you are talking about gain in dB, you know very well, you are supposed to 20 log of that gain, and that is omega. So 20 log of omega, right? And this will be phase. Okay, so yeah. So let us say we'll start with 10 raised to minus 2, 10 raised to minus 1, 0, that means I'll write 10 raised to 0, 10 raised to 1 and 10 raised to 2. Fine. Now in this case, when you are talking about omega, the same thing will get repeated. In the pole, you have seen that it was 1 upon omega. So all the signs get reversed. Here it will be the same. -2, -1, 0, 1 and 10 square. Okay, so 20 log of omega. If I put this omega over here, that raised to -2 will come on this side. So it will be -40 and log of 10 is 1. So -40 dB, then -20 dB, 0 से multiply होगा 0 dB, 10 raised to plus 1. Plus 1 means on this side 20, log of 10 is 1. So 20 dB and 2 on this side, so 40 dB. And no need to worry for angle. Yes, we know it is going to be 90 degrees for all. So no need to write 90 separately. Actually, it is constant for all. Done? Correct? So we'll try to see now on the Bode plot how we can draw it. So I am talking about magnitude over here and angle over here. So let us say this is 10 raised to -2. 10 raised to -1, 10 raised to 0, 10 raised to 1 and 10 raised to 2. Fine. And because we are in the range of plus 40 to minus 40, we'll make the partition 1, 2, 3, 4, 5. So it is 20 dB. 1, 2, 3, 4, 5, 40 dB. On the same line, 1, 2, 3, 4, 5. So if the theory question comes for these all parts, right, write everything and draw it. Yeah, 40 dB, sufficient. Yes. Here, now we'll mark those points. So I'll mark with red. Just see, 10 raised to -2, that is minus 10 raised to -2 के लिए gain is -10, -40. Okay, 10 raised to -1 के लिए -20. 10 raised to 0 के लिए 0. 10 raised to 1 के लिए 20 dB. Correct? And 10 raised to 2 के लिए this. So now we are supposed to join all these points to have the Bode plot of this particular function, that is a 0 at origin, which is equal to s, right? So I'll highlight these points so it will be easy for you to refer afterwards. Yeah, and this is graph of s and the slope is very much clear. यहाँ से यहाँ तक 1 decade के लिए change of the slope is of 20 dB. So it is going to be 20 dB per decade. Right? Okay. Angle के लिए we'll just say 90. So 1, 2, 3, 4, 5. See, I am taking 5 divisions is equal to 90 degrees. Now your choice how you want to take it, right? You may say one division is equal to 90 degrees, but it should be measurable. That's why it's your choice how you will keep the resolution. When you will actually do in the exam, your graph paper size, I mean the Bode plot semi log paper size will be much greater than this. So definitely you will be able to do neatly, more what we can say, with better resolution actually. Okay, right? Now the next thing is, yeah, now I'm talking about the second part, that is when you are having repetition of the pole at the origin. That means your GH of S will be equal to S square. So GH of j omega will be equal to j omega bracket square, which will be equal to minus omega square. So very well I can write minus omega square plus 0j. Okay, so if I am talking about the magnitude now, gh j omega, magnitude of that, correct, it will be omega square. Omega square square, nothing added, and again root, so it will be omega square, right? And angle of that it is going to be tan inverse of 0 upon minus omega square. So it will be tan inverse of 0, correct? Now tan inverse of 0 is going to be 0 or 180, but because the magnitude is see, if you'll have in the plane, right, 0 in this direction, okay, this one, and plus omega square, then angle will be 0, but it is minus omega square, so it will be in this direction. So 101% angle is going to be 180 degrees. Yeah, just wait. So if I want to draw the vector, now magnitude is omega square and angle is 180, that means I am supposed to draw it in this direction, and I'll say magnitude will be omega square, right, and the angle is 180, and this is the second case, right? Same thing we want to plot it over here. So first we'll try to get all the points. So same thing, omega, now gain is omega square, correct? So if I'm talking about gain in dB, it can be written as 20 log of omega square. So definitely this thing we can write it as 2 into 20 log of omega. So very well I can write 40 log of omega, and the phase will be same. It is not dependent upon the omega ka value, it is going to be 180. So whatever is the value of frequency, angle is going to be 180 only, right? So let us say 10 raised to minus 2, minus 1, 10, 10 raised to 1, and 10 raised to 2. So when you are talking about gain, it will be doubled. So square, not doubled, square of that. So minus 4, 0, 2, 4. Okay, 40 log of omega. Now 40 log of omega. So minus 2 on this side, minus 80 dB. Right, 10 raised to minus 1, minus on this side, minus 40 dB. 0 multiplied, so 0 dB. Then once I multiply, that means 40 dB and 80 dB. आप करके देखो, करेक्ट? तो फेस के लिए तो डेफिनेटली डायरेक्टली आई विल ड्रॉ इट, एंड इफ दिस इज 90, अगेन 1, 2, 3, 4 and 5. So this is going to be 180 ka line. So I'll draw that line. Okay, and this will be for S square. This is omega, I forgot to write on the axis, right? This is magnitude. And this is angle. Okay, so we'll mark the point. I don't think 80 will be fitted over here, but 40 ka definitely we will be able to draw. So 10 raised to minus 1 ke liye minus 40. So this point 10 raised to minus 1 ke liye minus 40, it is getting shifted over here. Then 0, again the origin, and 10 raised to 1 ke liye gain is 40 dB. So somewhere over here, correct? So I'll join the points. and very well understood. From this point till this point, 1 decade, and gain, change in the gain is of 40. So if I'm writing the slope of this slope is going to be 40 dB per decade. See why we are doing all these things, because we want to collect now individually if these components are there in the transfer function, what will the graph of that individual one, and then we'll be able to join all those things, right? And we can have the total overall transfer function of the system. What else I'm supposed to write? Yes, this is for S square. Correct. So we have done for if we are having single origin at single zero at origin, or even if you are having double zero at origin. Now single zero at origin means it is telling you it is type 1 system. When you will have double zero, that means it is telling you you are having type 2 system. 3 poles, type 3 system. So what will happen now? Again will be cube, correct? So will be multiplied by 3. So 60 means 120, and in that particular fashion the gain will change, and because of that the graph is going to change. The slope of the graph will keep on changing. Okay, let me save this. Yeah. Now, just a minute. I'll make changes in this graph only, so every time writing all these things and forming the axis will be tough for me. All these things are okay. Yeah. Okay. One more thing. Yeah. So we have completed the C part. Now we'll go for D. I don't know now whether we'll be able to draw the graph or not, W plane or not. If not required, I'll remove it. First, let me start with it. I don't think we'll require all these things. Yes, just a minute. Yeah. Now we'll go for when you are having a pole at on the real axis. That means real pole is existing, right? Then we'll see real zero. What will happen to the real zero? We'll try to see. Okay. So I've done. Yes. Okay. So I'm talking about a single real pole. So I'll write D. Single real pole. Okay, now when I'm trying to explain you real pole, keep in your mind I'm going to talk about one concept, that is cutoff frequency. Now cutoff frequency means what? See, normally, theoretically, what we want for any of the frequencies, right? What you want? You should have a straight line. Gain should be straight. There should not be any effect of the frequency. This will be theoretical thing. Practically, this is not going to happen. You will find in a particular range of frequency, your system behavior is very nice. On this side, it will not be good. On this side, it will not be good. Gain will start dropping. So you say this is bandwidth. Correct? Frequency range in which my system is going to perform perfectly as per my expectation, that we used to call it as bandwidth of the system. Now this point at which you will find, yes, your system is not behaving properly, you have to cut down. After this particular frequency, you are not supposed to give higher frequencies than this, right? That is called as cutoff frequency. Now how it is correlated over here, when I'll draw the Bode plot, you'll come to know. Okay, but in the starting you'll not understand that. Just let me write everything, then if you are having any doubt, definitely I'll clear your doubt on WhatsApp. Okay, so I'm just saying, let omega 0 be the cutoff frequency. Okay, then the second thing is, you are having a single real pole. Normally you used to write it as S plus A, something, and a real pole we are having. So this thing I can write it as, if I divide numerator and denominator both by A, I can have 1 upon S plus A. Agree? Now this is again gain. Gain we have taken care of in the first Bode plot only. So no need to worry for gain now. Right? So I'll not consider this factor taken out, so I'll consider this to be equal to 1, and S upon something, this A, I'm going to call it as omega 0. You will come to know when I'll draw why I'm calling this as omega 0, why it is acting like the cutoff frequency of your system. Every time it will act like a cutoff frequency. Why? When I'll draw, you'll come to know. Okay. So that's why I'm saying now the transfer function will be GH of S is equal to 1 upon 1 plus S upon omega naught. Okay, where is, okay, I have not substituted for S, so I'll substitute. GH of J omega is equal to 1 upon 1 plus J omega upon omega 0. Correct? I want real part and imaginary part separately, so I'll rationalize this. So is equal to, by this complex conjugate we'll multiply and divide. So you are going to have, okay, first I'll write the original thing and then I'll multiply and divide. Should not skip any of the things, otherwise it may confuse you. Multiplied by 1 minus J omega upon omega 0 upon 1 minus J omega upon omega 0. Fine. So is equal to, now this will remain as it is, minus J omega upon omega 0 divided by, yeah, see now 1 minus J square minus plus omega upon omega 0 with bracket square. Fine. Now we'll be able to separate the real and imaginary parts. So I'll write 1 upon yeah 1 upon 1 plus omega upon omega 0 square of this bracket, same bracket on this side, omega upon omega 0 plus का sign, right, plus j, and it is going to be minus omega upon omega 0. So I got the real part. And I got imaginary part also. So to get the magnitude, GH omega, magnitude of that, or we can say gain of that, right? I'll write gain is equal to magnitude of GH j omega, real part square minus plus imaginary part square. So I'll write in the root. Yeah. So what we'll get? A real part, that is 1 upon one plus omega upon omega 0 square, right? And square of this plus real part का square, अभी imaginary part का square. So minus omega upon omega 0. अच्छा, I'll put it square to the whole thing, plus omega upon omega 0 square of this and square of this imaginary part. Okay, so will be equal to, again under root only will write. Yeah, so we are going to have, see, 1 square and this square, so and the denominator is same, so I'll add 1 plus omega upon omega 0 square of that divided by, yes, square of this term. Both the terms are same, so I'll write 1 plus omega upon omega 0 square and again square of that. Alright, so you can see the same term over here. So one term will get cancelled out. It will be 1 upon 1 plus omega upon omega naught bracket square and root of that and in the denominator. So instead of jumping, I'll write first So I'll write, it will be 1 upon एक bracket cancel हुआ, हाँ. So you are going to get 1 plus omega upon omega 0 bracket square. Correct. So this one bracket is getting cancelled out. In the denominator you got only this bracket and it is in the denominator. So very well I can write 1 plus omega square upon omega naught square and whole thing raised to minus half because root का sign है. So I think gain is clear. Now we'll go for the angle. So पहले we'll get gain in dB also, so will be better. So gain in dB is equal to, see, 20 log of this magnitude. So it is 1 plus omega square upon omega 0 square raised to minus half. So if I'll take that minus half on this side, right, so it is going to be minus 10 log of 1 plus omega square upon omega 0 square. I think now it's very much clear. Now I would like to gain in dB. Correct. I'll make bracket for this because this is very important thing that we got. Yeah. Then the next thing is we want to get the angle, right? What is the phase of this? So we'll get phase of this. Okay, even if I'm writing log, I'm not writing the base. Now definitely I'm assuming that everyone is familiar with कि whatever log is there, it is to the base 10. I'm not writing every time. In the notes you will find that yes, I have written everywhere it is to the base 10. Okay, last slide also I forgot, but definitely you are aware of. Now I am talking about phase. So phase is tan inverse of, I'll not write everything, just see, tan inverse of imaginary upon real. So this thing in the denominator, because the same will get cancelled out, and it is going to be equal to minus omega upon omega 0. Correct? Right? Okay, I think we kept this thing, but still the calculations are remaining. So I'll delete all these things, and on the next, while drawing again we'll take this. Also maybe wasted time in. Okay, let it be. Yeah. So I'll delete this. Wait. And I'll make a partition. Yeah, so we got angle and we got phase. Now we'll see those conditions where, because two things are coming in picture, regular omega, the frequency which is variable, and one frequency that is omega naught. So possibly three cases are there. Let us say case number 1, where your omega is very much away from cutoff frequency, that is omega is very less compared with your omega 0, right? If this thing is there, and if you are talking about gain, of course in dB we are talking here about, so it is going to be minus 10 log of to the base 10 definitely, and omega is very less, that means this one will become dominating and this term will vanish, so it will be log of 1. Correct? That means log of 1 is 0, so gain is going to be 0 dB. Clear? Right? And the same line, when you are talking about phase for this, that I'll say phi. Okay, and this omega is very less compared with this. Definitely this is approaching towards 0 when your omega is very small, very small compared with your omega 0, right? And in that case it is going to be 0, tan inverse of 0, and tan inverse of 0 is 0. I'll write 0 degree. Clear? Now we'll go for case 2. Case 2, when you are having your omega is equal to omega 0 at the cutoff frequency your system is, right? In that case, this gain will be equal to minus 10 log of to the base 10, and these two things are becoming same, that means 1, that means 2. Now also you can work on your calculator and you will find that you are getting that thing to be equal to 3 dB. And in that case, phase, when you are saying, phase will be again comparable, right? And tan inverse of minus 1, so you are going to get it will be at 45, but in the minus 1, see, this is fourth quadrant. Correct? And you are getting tan inverse of minus 1, all silver, tea and cups, but you are having minus sign over here, so here tan is going to be negative and we want that value only, so definitely it is going to be minus 45 over here, right? Just a minute. Yeah, so I'll write tan inverse of minus 1, and that is going to be minus 45 degree. Now case number 3, where you will find this omega is very away from breakout or cutoff frequency, and that is very much away, very highly greater than the cutoff frequency. So in that case the gain will be minus 10 log of 10. See now because this is very large compared with this term will become dominating. Compared with 1, it will be very on higher side, so definitely you can neglect this, and it is going to be equal to omega upon omega 0 bracket square. So what I can write for this? Minus 20 log of to the base 10 omega upon omega 0. Now this thing is telling you that this gain is going to change, will have a slope of, or it will drop, right, by 20 dB per decade through 0, right, because over here when it was equal it is 0 dB. So when they are, see, right, over here, sorry, when they are equal it is minus 3 dB, but that minus 3 ka point will draw and you will come to know it is passing through 0 at omega equal to 0. At omega equal to 0 you will find that point is going to pass through the 0 dB ka line, and you are having minus 20 log 10 to the base 10 of omega upon omega 0. Now when this thing will be decade, 1 decade, that means 10. So log of 10 will be equal to 1 and the slope will be equal to minus 20. So this is telling you that the gain is going to drop. I'll write gain drops by, drops मतलब माइनस साइन वहाँ पे इंक्लूड हुआ, 20 dB per decade. Some of the books are writing B capital. I used to write it small, right? But no worry, you can go by any of the things. Gain drops by 20 dB per decade. Every time when this will be ratio will be 10, the dropping of the frequency will be, dropping of the gain will be at the rate 20 dB per decade, and passing through how it is passing through 0, I will draw and I'll explain you. At omega is equal to 0, at omega 0. Okay, so I'll save this and I'll clear. Yeah. So see, now we'll try to draw this graph. Graph means the Bode plot we'll try to draw for this particular case. So now we'll require graph paper. Just a minute. Yeah. Yeah. So see. I'll move this on this side now. Okay, so we have to draw all the axes. Just give me a minute. Okay, okay. So this is your magnitude plot. This is your omega. This is your phase plot. Okay, and what we are going to require, slope of minus 20 dB. So I'll just mark 1, 2, 3, 4, 5. This one is minus 20 dB. Fine. What else we are going to require? 45, minus 45 and minus 90. 1, 2, 3, 4, 5. Let us say now the scale I have changed. Minus 45 and 1, 2, 3, 4, 5. So minus 90. ठीक है. And we'll say these frequencies, let us say this is the point where your omega is becoming equal to omega 0. Okay, this is when your omega is very less than omega 0, and this is the thing where omega is very high, on higher side than omega 0. So see, I'll write cutoff frequency. And if you have understood the derivation part which I had written over there, right, you might have observed what is happening in this part. Actually the gain is 0 when it is on the lower side, correct? As soon as it is reaching, it is becoming 3 dB. So if I want to draw 3 dB, let me say 5 division F5 means 4, 1 division is 4 dB. So I will draw that line over here. Assume that this is 3 dB. Exact तो possible नहीं होगा. Okay. So let us say this is 3 dB, and I'll draw a line of 3 dB from this through this point, and I'll write over there that is this is 3 dB. Right? So at this point I'll mark with red. At when your frequency is equal to the cutoff frequency, the gain is 3 dB. Okay. After this, every per decade the change in the slope is becoming -20. So if I'm saying this is -20, and let me see where it is, 1 2 3 4 5, this point is -40 dB, right? See that. Now when the frequency is on lower side, yes, the gain is 0 and angle is also 0. Just a minute, if I can select it. Yeah. So it is on 0, correct? And then after this it is going to change by 20 dB. So per decade 20 means at this point it will be this bit. So -20 dB, it is going to be this point, correct? -40 dB, it is going to be this point. Yeah, I forgot to write, but I think okay, per decade, this line and this line, the difference is of multiplication of 10. So no, we cannot fix that, right? Because we don't know any frequency. So from this point, yeah, this is the approximate curve. I should not use this color, I'll use red only. So red is telling you that yes, your curve is this. So this is actually approximate, where I have drawn the straight lines. This is what we can say approximate curve. Okay. But the actual curve will be, now I am drawing actual curve with blue line. Okay. It will be at far end, it will be 0, but slowly it will start increasing, right? This will pass through this 3 dB and then it will go along this. So passing through 0 means what? Whatever will be this curve at infinity, if you will revert back and if you will try to pass through a straight line, if you will try to pass through, it will go through 0, and that's why through 0, the word which I have used, meaning of that. So I'll try to draw. Now I don't know how much accurately I'll be able to draw it over here. With blue I am drawing the actual curve. So ये 0 है, it will start increasing. It will start increasing at till this point, correct? And then I'll draw reverse thing. Yeah, this is better. Okay, so passing through 3 dB at omega equal to 0, and then along the 0, along this 20 dB ka line, it will, like asymptotically bolte hai, it will go asymptotically through it, along with it. Like this. Okay, so blue one is the actual curve. Okay, I'll highlight that 3 dB point, so you should not miss out that point. I try to clear. Oh, wait. Yeah, and this is 0. Yeah, it's okay now. Okay, on the same line, for angle now we want to write, right? So for angle, if we are writing, you know that initially I just draw approximate lines first, and light color we'll use. So let us say this is 45 ka line, angle 45, and the second one is for 90. Okay, so how it is going to vary? Again, I am drawing with blue or green. Okay, see now. Initially it is 0. At omega equal to omega naught, it is going to be 45, and then again it will go along 0. So as if ulta S you are going to have. Yeah, very good. This will be the curve for phase, right? Yeah, I should write over here. This is omega. So we have done with a single real pole. If we are having, then what will be the Bode plot of that? Now we'll go for single real 0. If we have, then what will the Bode? Keep in your mind. कितना भी आप मैथमेटिकली कर लो या आप कितना ही ड्रॉ कर लो, राइट, ट्राई टू रिमेंबर इट लॉजिकली. सो कीप इन योर माइंड, अगर आपका सी when it was pole you got decreasing gain, right? When it was 0 it was increasing slope, not gain, slope, right? Gain also and slope also. Here you got, because it's a pole, you got it decreasing on this side. When it will be a 0, you will find exact mirror image along the real axis you are going to get. I'll derive for you, that is not the thing, but ultimately when you are going for the actual solving numerical, no, don't keep on remembering everything, just logically try to think and try to remember for this. So I'll write what we did. This Bode plot is for single pole, single real pole. Okay, now if we'll have double नहीं, अभी सिंगल रियल 0 के लिए जाते हैं. Yeah, so I'll write now single real 0. Now because we have done it for pole, now it will be very easy for us to go for 0. And again omega naught. So why we said omega naught? Because at this, why we are comparing at this point? Because this is the changeover point. At this point only you will find, yes, again will start dropping, and that's why this is called as the cutoff frequency. इससे पहले system was fine. After that you will find, yes, it is having cutoff frequency. The gain starts dropping. That's why this point is called as cutoff frequency. And in the derivation we had found out that, yes, at this point the major changes are there in the curve, correct? That's why we are considering this. Okay, so I am talking about omega as the cutoff frequency. ठीक है. So GH of S is equal to, normally कैसा होता है, S plus A in the numerator. So I am not writing in this way. I am going to write 1. अच्छा, पहले मैं I will write it as 1 plus S upon something, and that something is going to be always cutoff frequency. So if I am writing GH j omega, then it is going to be 1 plus j omega upon omega. No need to separate the real term and imaginary term. Very well clear. 1 and omega upon omega 0. So we'll try to get gain for this. Gain, which we write it as GHJ omega ka magnitude, and very well you are aware of, it is going to be equal to under root under root 1 square, that is 1 plus omega upon omega 0 bracket square, right? Okay, so very well I can write it as 1 plus omega upon omega 0 whole thing raised to minus half, raised to half, माइनस नहीं अभी, अच्छा स्क्वायर लिखना रह गया, स्क्वायर एंड रेज टू माइनस हाफ. क्लियर है? करेक्ट. Now the same line, if you want to go for now gain in dB, then what we will write? 20 log of to the base 10 1 plus omega upon omega 0 bracket square and raised to half. So I'll take this thing on this side, so it is going to be 10 log of to the base 10 1 plus omega upon omega naught bracket square. Yeah, okay. So we got the expression for the magnitude. Then we'll go for the phase. We'll represent it as phi. See, phase के लिए real part upon imaginary part. So it is going to be tan inverse of, imaginary part upon real part. So it is going to be tan inverse of omega upon omega 0. Right? So I'll write it over here, gain in dB, and we'll make bracket for this, because these are the two things we are going to use for all the three possible conditions. So let us see what we get for three conditions where omega is very large, omega is equal to cutoff frequency, and omega is smaller than cutoff frequency. So I'll say case 1. When omega is very small compared with omega 0. Okay, so gain. Now very small means 1. Okay, I'll substitute over here. Very small means compared with this very less. Compared with very less means 1. Correct? Now this will be 20. So again it is going to be 0. Because it will be log of 1. And log of 1 is going to be equal to 0. So very well we can write magnitude to be equal to 0 dB. Yeah, I'll write gain in dB is equal to this. I'll write 10 log of 10 to the log of 1 to the base 10, which is going to become equal to 0 dB. Yeah. Then the phi angle, right? This is very small. Very small means tan inverse of 0. That means ultimately at the end, right, very less frequency, it is going to reach to 0. Then I am talking about case 2. for case 2, when omega is equal to omega naught. When they will be comparable, correct? This will be, I'll write gain in dB is equal to 10 log to the base 10. When they are equal, there will be 1, so log of 2. So it will come out to be 3 dB now. Previously it was minus 3 dB. Here I forgot to write minus sign, minus 3 dB. So here it will be plus 3 dB. Okay. And phi angle tan inverse of, both are same, but minus sign is not there, so 1, so it is going to be 45. So you can see the graph is getting reversed, so it will be in this way, going like this, and this one will be also, you will find it is going like this. Same cases we are getting, because right. Then I am talking about case 3, where omega is very much on higher side compared with omega 0. So now this is becoming comparable, so it will be omega square. So I'll write gain in dB is equal to, this 2 I'll take on this side, so it will be 20 log of 10, right? And omega upon omega 0 bracket square. So now square to gaya na, square we had taken on this side. So this thing. So every there is decade, that means the frequency is 10 times greater than this. You will find that yes, it is going to increase because plus sign is coming by 20 dB per decade. And of course, again it will, if you will proceed it back, it is going to pass through 0 ideally. So I'll write gain increases by 20 dB per decade. Yes, okay. And phase, if you are finding, very well understood, very high value compared with this, so tan inverse of infinity ultimately, and it is going to be 90 degrees. So exact reverse with the sign, everything you got. Right now we want to plot this. So let me save. Yeah, and just give me 1 minute. So all the cases are with you now, correct? So because definitely I would like to use the same graph, so no need to write it again. And then I'll stop. Complex pole and 0 I'll take in the next lecture, in the next video. Just a minute. Yeah. Yes. Yeah. So it is going to be single real 0 now. Okay, 0 ke liye we are doing, and yeah, all these things we require, but the curves will not require. Oh, let it be this thing. Will not require all these things. Yeah, and this plot also will be on the upper side because we got 45 and 90. Okay. So I'll shift this line over here. Okay. Right. Yeah. Right. So I'll write now. This is going to be 1, 2, 3, 4, 5. So it is 20 dB. 1, 2, 3, 4, 5, 40 dB. So 5 divisions means I'll draw the line of 3 dB on the upper side. I think I should rub this also, and I'll draw it. I'll write it on the lower side. Will be better. Yeah. So just I'm drawing 3 dB ka line. See, 5 divisions 20 dB. That means per division 4. So slightly on the lower side. So I'll write 3 dB. 3 dB line. Okay. Then I'm writing it over here now. Omega is very less than omega naught. Omega is equal to omega naught, and omega very higher side compared with omega naught. So definitely this line is not going to change because magnitude 0 and angle is also 0. Correct? Then this point will be of 3 dB. This point. And I'll put the lines with, from this point onward, for every decade, it is going to be 20 dB ka slope. Okay, so we are talking here about theoretical or ideal curve, or we can say approximate curve also, because never you are going to achieve this. And this one is single real 0 now. Yeah. Okay, but how the curve will be there? Yes, I'll draw it with red. So it came over here, right? So it will not be actually this. It will go along this, and from this point I don't know whether I'll be able to draw it now. Will pass through this point 3 dB and will go along this asymptotically. So I can say yes, actual curve. Fine. And this point is of 3 dB. Yeah. Okay. Then the next thing is for phase. 1, 2, 3, 4, 5. Let us say 45 and 5. So 90. This is the breakout frequency, so, or cutoff frequency. So at this point it is going to be this, which it should pass, and it should go to 90. So I'll draw that line. Yes. So if I want to draw the curve, it should be with a 0. Yeah, then it is passing through this point 45 degree at breakout frequency, and it will go along this. Alright, so I'll put red color for this point, which is important. So we have done with gain, right? Pole at origin, 2 poles at origin, 2 zeros at origin, single 0 at origin, a single pole and a single 0. Rest of the things we'll do in the next lecture.